All right, let's talk about a piece of tech that quietly powers a huge chunk of the modern internet, webhooks. If you've ever wondered how different apps seem to talk to each other almost instantly, well, this is how they do it.
So let's paint a picture. Let's say you've built a killer e-commerce app, and you're using a service like Stripe to handle the payments. Now, a customer buys something. Your app needs to know, like right now, when that payment succeeds so you can ship the product, send the receipt, the whole deal. So how does your app find that out?
Well, you could just ask over and over again. Your app could ping Stripe every single second for every single order, going, "Hey, is order 123 paid yet? How about now? Is it done now? Now?"
This method of constant checking, it has a name. It's called polling. And while it might kind of work if you have like 2 customers, it's a total nightmare at scale. I mean, can you imagine a massive service trying to do this? It would just be a constant storm of useless network traffic, burning up resources for both you and the payment service. Just not a good look.
But what if, instead of your app doing all the work, what if Stripe could just tell you? What if it could just send your app a quick message the instant that payment goes through? I mean, that would be way better, right? Well, that's exactly what webhooks are for.
Yeah, this simple flip of the script is often called the will call you principle, and it's the really powerful idea that makes webhooks tick.
So, at its core, a webhook is just an automated message. It's one system sending a simple HTTP request to another system to say, "Hey, that thing you were waiting for? It just happened." Instead of your app constantly pulling information, the service pushes it to you, in real time.
The best analogy I've ever heard is a busy restaurant. You don't just stand there by the host's stand asking every 30 seconds if your table's ready. No way. You give them your number, and they text you when it's time. You get notified. That's it. A webhook is basically the digital version of that text message.
And this slide right here breaks it down perfectly. On the left, you've got polling. Your app is just this annoying kid in the backseat going, "Are we there yet? Are we there yet?" But on the right, you have webhooks, which flips the whole thing around. The service just tells your app, "Hey, we're here." It's simple, it's elegant, and it's a push, not a pull.
Okay, so the theory is cool, but how does this stuff actually work in the wild? Let's walk through a super common example.
Let's use GitHub. Say you want to run some automated tests every time a developer opens a new pull request. So first thing you do is go into your GitHub settings, and you give it a special URL from your app. This is your webhook URL. You also tell it which events you care about. In this case, just the pull request event. Now, the moment someone creates that pull request, GitHub instantly packages up all the info about it into a JSON payload and fires off an HTTP post request straight to your URL. Your server catches it, makes sure it's legit, and kicks off your tests. That entire automated flow, all powered by one simple webhook.
So what does that notification from GitHub actually look like? What's in the box? It's not just a simple ping, it's a structured request that's packed with all the info you need. Let's take a look.
So the request comes with these things called headers. They're like the label on the outside of the package. You've got content type, which tells your server to expect some JSON. You have an X event type, which says exactly what happened, a pull request in our case. Then there's a unique X request ID, which is a lifesaver for logging and debugging. And most importantly, you have this signature header. It's all about security, and we'll circle back to that in just a second.
And then you have the body of the request. This is the good stuff. It's a JSON payload that has all the juicy details about what actually happened. Who opened the pull request, its title, the branch it's for. Everything your app needs to do its job is right here.
Okay, so receiving these messages seems easy enough, right? But doing it the right way, securely and reliably in a live production environment, that takes a little more thought. You basically need to build a digital bouncer for your app's front door.
Because in the real world, things can get messy. The service might accidentally send you the same event twice. Or your server could go down for a minute and miss a notification. And since your webhook URL is just a public endpoint on the internet, you better believe people are going to try to send you fake, malicious requests. You have to be ready for all of it.
So that first problem, duplicate events, is solved with a concept called idempotency. It's a bit of a fancy word, but the idea is really simple. Doing the same thing more than once shouldn't cause any problems. And the way you do this is by using that unique request ID we saw earlier. Before you process an event, you just check, have I seen this ID before? If the answer is yes, you just ignore it. Simple as that.
But that doesn't help with the biggest risk of all, security. Your URL is out there for the world to see. So how in the world do you know a request actually came from GitHub and not some attacker trying to mess with your system?
And the answer is signature verification. Think of it like a secret handshake. When you set up the webhook, you and the service provider agree on a secret key, a password that only you two know. Then, for every single message it sends, the provider uses that secret to create a unique encrypted signature. When your server gets the message, it runs the exact same calculation. If the signature you create matches the one they sent, you know it's legit. If they don't match, you just toss it out, no questions asked.
Okay, so your webhook receiver is secure, it's reliable, but what happens when you go from getting a few events an hour to thousands a second? That's when you have to start thinking about a whole new level of architecture.
Yeah, that simple server endpoint that just takes the request and processes it right away, it's going to fall over, hard. If you get a huge burst of traffic, it'll get totally overwhelmed. The key here is to separate the act of receiving an event from the act of processing it. You need to go asynchronous. This is what a real production-grade system looks like. Your public webhook endpoint does one and only one very fast job. It validates the request and then immediately drops it into a message queue, like AWS SQS or Kafka. That's it. Then you have a totally separate fleet of background workers that can pull events from that queue and process them whenever they're ready. This makes the system so much more resilient. If a worker fails, the event just goes back in the queue to be tried again. And if an event keeps failing over and over, it gets moved to something called a dead letter queue, so a human can look at it later without blocking up the whole system. And of course, with a system like this, you can't be flying blind. You absolutely have to have good monitoring. You've got to track your success and failure rates, how long it takes to process things, but the most important one is queue length. If you see that queue length start to climb and stay high, that's your canary in the coal mine. It's an early warning sign that your workers can't keep up.
You see, this separation, this decoupling, is the whole secret sauce to scaling. By putting that queue right in the middle, you've essentially built a giant shock absorber for your system. It can handle massive, sudden spikes in traffic without even breaking a sweat. It's just rock solid.
So, from your Stripe payments to your GitHub commits to real-time chat apps, webhooks are the invisible glue holding the modern event-driven web together. They let all these different services react instantly when things happen. So the web is built on events. The only real question left is, what are you going to build with them?